You walk into this massive office building right in the dead of July, and it is a sweltering, humid 95 degrees outside.
Yeah.
It's like the kind of heat that practically bends the asphalt.
Yeah, the heavy, sticky heat.
Exactly. But the second those heavy glass doors slide open, you're hit with this crisp, perfect 72-degree air. And we usually treat it like magic. Just a plastic thermostat on the wall that we blindly trust to just keep the indoor world habitable.
Right. There's definitely an illusion of simplicity there. We enjoy the comfort, but we rarely consider the massive complex arteries hidden behind the drop ceilings,
Right.
or the fluid dynamics, or the high voltage electrical systems making that comfort possible. We just assume the building breathes on its own.
But then you step into the reality of the people who actually build and maintain those systems, the HVAC and refrigeration technicians. And suddenly you realize that thermostat is just the user interface for a highly regulated, incredibly complex mechanical universe. So today we are going deep into the landscape of Canadian HVAC and refrigeration certifications. And specifically, we're zeroing in on Ontario's standards. We've got a stack of industry guidelines here, curriculum breakdowns, and regulatory frameworks. And our mission today isn't just to list requirements, right? It's to understand the architecture of this profession. Like, how does someone legally earn the right to control the climate in our homes and skyscrapers?
And that architecture is surprisingly rigorous. I mean, the HVAC certification world in Ontario is primarily governed by an organization called Skilled Trades Ontario, or STO.
Okay, STO.
Yeah, STO. And they divide the core refrigeration and cooling landscape into two main licenses. First, you have the 3113, and this is the commercial license. Officially, it's titled Refrigeration and Air Conditioning Systems Mechanic. And then you have the 313D, which is the Residential Air Conditioning Systems Mechanic.
Now, looking at the structural differences between those two, my notes emphasize that the 313A commercial license is a Red Seal trade. I know the Red Seal is a pretty big deal in Canadian trades, but practically speaking, what does that classification actually unlock for a technician?
Well, think of the Red Seal as a federal passport for your career.
Okay.
Canadian trades can be highly provincial. Like, what qualifies you in one province might not mean anything in another province.
Right.
But the Red Seal program unifies those standards. So if you earn your 313A Red Seal license in Ontario or, say, Nova Scotia, you can pack up your tools, move to British Columbia, and immediately start working at the highest level. You don't have to retake the exam. Your mastery is federally recognized across the entire country.
Wow. But the 313D, the residential license, that one lacks that federal passport.
Correct. Yeah, the 313D is currently an Ontario-specific license. Other provinces might eventually adopt a residential-specific tier, down the road.
Sure.
But right now, if you go to STO in British Columbia, for example, they only recognize the commercial equivalent.
I see.
So if you're a residential guy in Ontario and you move west, you run into a bureaucratic wall. Okay,
let's unpack this a bit, because I want to look at the barrier to entry here, because it completely shatters the stereotype of trades just being, quote-unquote blue-collar manual labor.
Yeah.
To even get a seat at the table for the 313A commercial license, you are required to complete 9,000 hours of apprenticeship work.
Yeah.
I mean, if you're working a standard 40-hour week, 50 weeks a year, that is 4.5 years of your life.
Yeah.
That's not a certification course. That's the time equivalent of a medical residency.
It absolutely is. And it's a highly structured residency, too. Within those 9,000 hours in the field, a 313A apprentice also has to complete 720 hours of in-college theory.
Wow.
And that's spread across 3 distinct levels of schooling. You are essentially earning a specialized applied engineering degree, but executing it on a rooftop in the freezing rain.
That's a great way to put it. And the 313D residential license.
It's a bit more streamlined, which reflects the smaller scale of the equipment. So the 313 requires 4,000 hours of apprenticeship.
Okay, so about half.
Roughly, yeah. And that includes 360 hours of in-college theory, split across just 2 levels.
Think about your own career trajectory for a second if you're listening to this. Does dedicating 9,000 hours to mastering a single, highly complex domain feel like an insurmountable mountain to you? Or is that just the necessary dues for becoming a true master of a craft?
It forces a level of commitment that really weeds out the casually interested very early on. Because those hours aren't just about holding a flashlight or fetching tools for somebody. They're about absorbing a deeply complex curriculum.
Right, and here's where it gets really interesting. Let's actually decode that curriculum. STO breaks this massive amount of knowledge into distinct levels. I want to know how the residential and commercial paths diverge on paper. What exactly is the difference between a residential and commercial tech on paper, and what are they learning in those college hours?
So STO structures this progression really beautifully, I think. Level 1 is the basic level, and it serves as the common ground. So both 313A commercial and 313D residential apprentices sit in the exact same classes for this.
So what constitutes the baseline? What are they both learning?
It's the foundational physics and mechanics. They cover safety and basic trade practices naturally, but then they dive into fundamental heat energy, the actual thermodynamics of how heat moves and how we manipulate it.
Interesting.
Yeah, they study basic mechanical cooling cycles and the core components of a refrigeration system.
And I imagine they have to heavily lean into electrical work too, right?
Crucially, yes. They spend a significant amount of time on electrical fundamentals. A modern technician cannot troubleshoot a failing compressor if they don't understand the high voltage contactor feeding it or the low voltage control board giving it the signal.
That makes total sense.
And they also drill the hands-on essentials.
Ah.
Soldering, brazing installation, and maintenance.
Okay, so level 1 establishes the laws of physics and the basic tools of the trade for everybody. But level 2 is the intermediate stage, and this is where the road splits.
Exactly. This is where the sheer scale of the machinery begins to dictate the education. So for the 313D residential technicians, Level 2 focuses heavily on residential psychrometrics.
Which is what exactly?
It's the study of air and moisture properties, so they learn residential load calculations, figuring out exactly how much heat a specific home gains in the summer and loses in the winter. They study heat pumps, air conditioners, warm air distribution systems, and specific residential electrical systems.
And there is a hard physical ceiling on this license, right? My sources explicitly state the 313D maxes out at equipment under 5 tons of refrigeration.
That is the defining line. 5 tons of cooling capacity is essentially your standard large suburban home.
Right.
Anything above that, the physics and the equipment architecture change drastically.
Which brings us to the 313A commercial track.
Mm-hmm.
What does level 2 look like for the heavy-duty side?
For the 313A track, Level 2 drops the residential focus entirely. They pivot to equipment strictly over 5 tons. This means diving deep into pressure enthalpy diagrams.
Oh, wow.
Yeah, they study commercial load calculations, commercial cooling components, and large-scale system design.
Let's pause on that on the pressure enthalpy diagram, because that sounds like pure engineering. What is that, and why is it so vital for commercial systems?
It really is. A pressure enthalpy diagram is a visual mathematical map of a refrigerant's thermodynamic journey.
Okay.
It charts exactly how a fluid behaves as it changes from a liquid to a gas under varying pressures and temperatures.
So why is it different for commercial?
Well, in a residential system, things are relatively standardized. But in a custom commercial system, if a technician needs to diagnose why a system is underperforming, they literally have to plot the system's operating conditions on this chart to see where the physical properties of the refrigerant are failing. It is hardcore applied physics.
Wow. And that's just level 2. The residential techs are done with college at this point, right?
Yeah.
But the commercial apprentices still have to tackle level 3.
Right. And level 3 is strictly 313A only. This is the advanced tier.
What's in it?
They get into advanced psychrometrics. Managing the moisture and air properties, not just for a house, but for, say, a 50-story skyscraper or a hospital where air quality is literally a life or death metric.
Oh, man.
They learn commercial heat loss and gain calculations. And then they hit the heavy machinery. Massive rooftop units, complex chillers, absorption systems, cooling towers, and evaporative condensers.
The outline also mentions ammonia systems. Why is ammonia in a cooling curriculum? I mean, I associate that with industrial cleaners, not air conditioning.
Yeah, ammonia, known technically as R716, is one of the most efficient refrigerants on the planet.
Really?
Oh, yeah. Especially for massive industrial applications like cold storage or food processing.
Yeah.
It has incredible heat absorption properties and zero global warming potential.
But there's a catch.
A huge catch. It is highly toxic and corrosive. If a residential Freon system leaks, it's bad for the environment and the system stops cooling. If a commercial ammonia system leaks, it can be lethal to anyone in the building.
Oh, wow. So level 3 is teaching you how to manage systems that are highly efficient, but fundamentally dangerous.
Precisely. You need specialized knowledge to handle it. Add to that the curriculum on commercial distribution and highly advanced electrical and electronics, and you see why this takes years to master.
And they aren't just learning this via, oral tradition from old journeymen on the job site. The sources lists the specific textbooks used for all this, and these are basically the Bibles of the industry.
They are.
We're talking about Whitman's refrigeration and air conditioning technology, modern refrigeration and air conditioning, the highly specific commercial refrigeration for AC technicians for the 313A track, and Smith & Russell's electricity for HVAC.
Yeah, those texts are dense, exhaustive manuals. They provide the irrefutable theoretical backing for every single turn of a wrench in the field.
So looking at that level 3 list, ammonia systems, commercial chillers, does that sound exciting or overwhelming to you?
Oh.
It certainly reframes the guy driving the service van, doesn't it?
It definitely demands a profound level of respect for the profession.
But here is where we hit a massive logical speed bump in this deep dive. Because we are talking about Canada. We are specifically talking about Ontario, a place that gets famously brutally cold.
Yes, it does.
We've just spent all this time talking about psychrometrics, refrigeration, cooling towers, and chillers. So what does this all mean if I want to fix a furnace in the middle of an Ontario winter? Do these 313 licenses cover me?
This is perhaps the most crucial and honestly often most confusing distinction in the entire Canadian trades landscape. The answer is absolutely not.
Wait, really?
Really. The 313A and 313D licenses are strictly for refrigeration and cooling. Heating falls under a completely separate legal and educational category, the gas technician licenses.
I want to make sure I understand this. The physics of moving air through a duct in a house is governed by SPO if the air is cold, but someone entirely different if the air is hot.
Essentially, yes. The 313 cooling licenses are managed by Skilled Trades Ontario, but gas licenses, those are governed by the TSSA.
TSSA.
Yeah, the Technical Standards and Safety Authority. It's a completely separate regulatory body from STO.
To use an analogy, it's like having to get your driver's license for the steering wheel from the DMV, but you're licensed to use the gas pedal from the Department of Transportation. Why the split? Why not just one HVAC license?
It comes down to historical safety paradigms. Refrigerants operate under high pressures and deal with environmental hazards. Natural gas and propane, however, are highly explosive and pose immediate carbon monoxide risks.
Ah, I see.
So the regulatory bodies evolve separately to manage those distinct risks. The TSSA manages the gas side with its own tiered licensing system.
How does that work?
Well, G3 is the lowest entry-level permit, G2 is the intermediate standard working level, and G1 is the master level, which allows you to work on massive industrial burners.
Okay, but let's look at the industry reality here. If I'm an apprentice, and my goal is to get a job at one of the major residential HVAC companies in Ontario, places like Reliance or Enercare, what does my resume actually need to look like to get in the door? Do I need both?
Yes. The absolute bare minimum combination you need to be employable at major residential companies like Reliance or Enercare is a 313D residential cooling license plus a G2 gas license.
So you need the combo platter. You have to satisfy both bureaucracies.
Yeah, and you have to. Because these companies are dispatching technicians year-round. They need a tech who can fix a seized air conditioner condenser in July and then diagnose a cracked heat exchanger on a gas furnace in January. If you only have one half of that equation, your utility to the company drops massively.
Are there any exceptions to this? Like, is there anyone who just works with the STO cooling licenses and just never touches a gas line?
There are highly niche exceptions. For example, if you are a commercial refrigeration tech who strictly works on supermarket display coolers or walk-in freezers or ice machines, you only deal with coolers. In that hyper-specific role, you wouldn't necessarily need the gas license. But if you are in general commercial HVAC or any residential work, you absolutely need both.
It's a classic bureaucratic split. Cooling by one agency, heating by another. Does breaking up trades like this make sense to you? Or does it just add unnecessary red tape for the people trying to build our infrastructure?
It certainly creates a steep administrative mountain, which actually brings up an interesting dilemma for a very specific demographic of technicians.
Right, because 4 to 6 years of apprenticeship plus navigating 2 different agencies is a massive undertaking for, say, an 18-year-old just starting out. But what if our listener is a seasoned veteran? Like, what if they have years of experience working as an HVAC tech outside Canada? Or maybe they've been working in a non-union, unlicensed capacity domestically for years. Do they seriously have to start from scratch at level 1?
Thankfully, no. The system does recognize prior experience. If you have the required background, there is a pathway to bypass the apprenticeship entirely. It's called the challenge process.
Challenging the exam. That sounds very, very dramatic.
Yeah.
What is the actual mechanism of challenging?
A core currency here is proof of hours. If you can definitively prove to STO that you already have the required hours, again, that's 9,000 hours for the 313A commercial, or 4,000 hours for the 313D residential, working as an HVAC tech domestically or internationally, you can apply to challenge the exam.
And if STO approves your application, what happens then?
You get to bypass all of the schooling.
Wow.
You do not have to take any college courses. You go straight to the desk to write the final certification exam.
That is a massive shortcut.
Yeah.
I mean, you are buying back years of your life. But proving 9,000 hours to a government agency can't be simple.
No, it isn't. And it's fascinating how wildly the burden of proof varies depending on which province you are dealing with. Let's compare British Columbia to Ontario.
Okay, let's look at BC first. How does it work there?
In British Columbia, the process is relatively simple. You basically need to submit 2 PDF forms that are signed and stamped by your current or previous employer.
Just 2 PDFs.
Yeah. And then STO in BC will make a direct phone call to that employer to verify the details. Assuming everything checks out, the entire process takes about 2 to 4 months to get approved.
That sounds entirely reasonable. 2 forms and a phone call. What is Ontario doing differently?
Ontario is much more complex. They demand an exhaustive level of detail. You need the standardized forms, sure, but you must also submit a highly detailed resume. And this isn't a standard one-page LinkedIn summary.
Right.
They want to see the specific projects you worked on, the exact geographic locations of those projects, a granular breakdown of the specific tasks you performed, and the precise durations of each job.
They want the raw data of your entire career, essentially.
And all of this must be printed on official company letterhead and physically signed by the employer.
Wow.
Historically, parsing all this documentation meant the Ontario process took 4 to 6 months, though recent data notes that STO has been processing them in about 3 months lately.
That's a bit better.
It is, but make no mistake, STO will make international phone calls to verify your overseas experience. They rigorously audit these applications.
I want to ask about something else here, too. What if someone emigrating to Canada has a university degree? Let's say they have an engineering degree or a highly technical IT degree from another country. Does that help them bypass the STO requirements? Surely a thermodynamics background counts for something.
It is a very common assumption, but the answer is absolutely not.
Really? Not at all?
Not a single hour. STO only cares about hands-on technician experience. A university degree, even in mechanical engineering, does not grant you exam eligibility.
That is wild. So an engineer who designed the chiller still has to start as an apprentice if they want to physically repair it in Ontario.
Legally, yes. Now, that being said, having an engineering background makes understanding the advanced concepts significantly easier. Like psychrometrics and load calculations are a breeze for someone with a mechanical engineering degree. They will grasp the theory immediately to pass the actual test. But the degree itself doesn't get you past the bureaucratic bouncer at the door.
If you had to prove your last 9,000 hours of work on paper right now, how easy would it be to track down your past employers and get them to vouch for every single project detail on official letterhead? It's a staggering administrative hurdle.
It requires meticulous record keeping. But getting that golden ticket, the approval letter from STO to challenge the exam, that is just the beginning. The exam itself is a whole different beast.
Okay, let's get into the room. You've got your approval. You sit down at the desk. The test is in front of you. Now, my notes say it's a multiple choice format, and I've taken multiple choice tests. Even if you're stumped, you can usually eliminate 2 wrong answers and guess. How hard can it really be?
The sources are unequivocal about this. It is a notoriously difficult, grueling exam. Let's look at the parameters. You are facing between 120 to 135 multiple choice questions.
Okay.
And you have a massive 4-hour time limit.
4 hours of multiple choice. That is a marathon. But still, if you've read Whitman's Refrigeration Technology cover to cover, shouldn't you be fine?
No, because it is a job-based exam. It's not about memorizing formulas. It asks highly specific, practical troubleshooting questions.
So real-world scenarios.
Exactly. Things you won't find in textbooks only in the field. It presents complex scenarios that you only understand if you've actually had your hands deep inside a malfunctioning commercial chiller.
So it's testing applied diagnostic logic.
Yeah.
But beyond the technical stuff, what makes it so tricky?
The language barrier. The English grammar and sentence structure used in these questions are highly tricky and deliberately confusing, even for native-born Canadians.
Seriously?
Yeah, they frequently use double negatives, or they will describe a symptom in a way that sounds like an electrical failure, but buried in the syntax is a clue that it's actually a mechanical restriction.
You aren't just troubleshooting the HVAC system, you are troubleshooting the examiner's grammar. So how do you even prepare for a 4-hour mental wrestling match like that?
You cannot study randomly. You must break the material down module by module, dedicate time purely to electrical, then purely to psychrometrics, then components.
Compartmentalize the knowledge.
Right, and doing timed categorized mock tests is essential to train your brain, your eyes, and your physical stamina, because you don't want to burn out by hour 3. If you haven't trained for that specific exhaustion, you'll start misreading those double negatives and making careless mistakes.
Have you ever taken a standardized test where the fatigue was a bigger obstacle than the actual questions? Like, how do you pace yourself for 4 hours of intense focus?
It is exhausting, but the reason technicians put themselves through this 4-hour torture chamber is because the payoff at the end is incredibly lucrative.
Let's talk about that light at the end of the tunnel. We've established the pain. Let's look at the game.
Yeah.
What does a licensed tech actually make?
The sources provide the exact 2024 wage figures, and they are immense. Working for unionized companies like those under Local 787 or RAC provides immense job security and top-tier pay.
Break the numbers down for us. Let's start with the 313D, the residential mechanic.
For a 313D residential tech, the base pay is roughly $42.96 to $43 an hour. But with the full benefits package, it's around $53 to $55.86 an hour.
So what does that translate to annually?
Annual income is $75,000 to $100,000.
Up to 6 figures for residential work. That is excellent. Now, what about the 313A commercial Red Seal folks? The ones who did the 9,000 hours and the ammonia systems.
For a 313A commercial journeyman working in Zone 1, which is the Greater Toronto Area, the base pay is $60.54 an hour.
Wow. Just base pay?
Correct. With the benefits package, it's about $78.50 an hour.
That is massive.
It puts their annual income comfortably between $100,000 and $150,000.
150 grand a year. Which, of course, triggers the ultimate DIY question for anyone listening. What if I just want to skip the license and work on my own house or do cash jobs? Can't I just buy a textbook and figure it out?
Legally, absolutely not. In Canada, you cannot touch electrical, plumbing, or HVAC systems without a valid license or working directly under a licensed tradesperson.
So side hustling AC repair is entirely illegal.
100%. Now, there is one highly specific rare exception in Ontario.
There's always a loophole. What is it?
A homeowner of a completely detached house can legally install their own furnace.
Really? Just me in a YouTube tutorial.
Technically, yes. But I strongly warn against this. It will void your home insurance if anything goes wrong.
Which is catastrophic.
Exactly. And even if you risk it, you can't legally buy the refrigerants anyway because they require an ODP card.
ODP.
Ozone Depletion Prevention certification. And beyond that, supply houses won't sell parts to you without a license, so it's a massive risk.
Given the 6-figure salary and the strict legal barriers to entry, do you think trades like HVAC are the most overlooked path to wealth today? Something to mull over the next time you walk out of the 95-degree heat and feel that perfect blast of 72-degree air.